Have you ever wondered what happens to that perfect strawberry before it becomes the jam on your morning toast? Today we're going behind the scenes of industrial food production to uncover the fascinating journey from fresh fruit to the sweet spread millions enjoy daily. What you're about to discover might completely change how you look at that simple jar in your kitchen. The jam industry represents a massive $5 billion global market, with countries like France consuming nearly 1 million tons annually. But despite this enormous scale, the fundamental process remains surprisingly similar to what ancient civilizations developed thousands of years ago. The Egyptians and Romans first discovered they could extend fruit's lifespan by cooking it with honey, creating the earliest versions of what we know today as jam. When sugar became widely available during medieval times, Arab innovators refined these preservation techniques and introduced them throughout Europe. The Industrial Revolution then transformed jam from a household necessity into mass-produced goods, while the 19th century brought us airtight containers that made these products accessible to everyone. Scottish companies like Keeler and Sons pioneered commercial jam manufacturing, establishing production methods still used in modern factories. Our journey begins in the Scottish countryside, where we'll follow strawberries from harvest to your breakfast table. The entire process hinges on one critical factor that determines everything that follows: fruit selection. This isn't just about picking the ripest berries. It's about identifying fruit at the exact moment when sugar content, acidity, and texture align perfectly for jam production. Strawberries destined for commercial jam production grow in dedicated fields, carefully monitored to ensure consistent quality. Harvest timing becomes crucial because fruit quality deteriorates rapidly once picked. Workers must identify berries showing optimal ripeness while rejecting any displaying fermentation signs, mold growth, or physical damage that could contaminate entire batches. The race against time starts immediately after harvest. From the moment fruit leaves the plant, natural processes accelerate, respiration increases, moisture evaporates, and ripening continues even after picking. Any mechanical damage during harvesting makes fruit vulnerable to microbial growth and premature spoilage. Transportation to processing facilities must happen within hours, not days, to maintain the quality standards commercial jam production demands. Upon arriving at the processing plant, trucks full of strawberries undergo immediate weighing and temporary storage in climate-controlled environments. The first major processing step involves thorough cleaning using pressurized water systems designed to remove soil, dust, pesticide residues, and other contaminants without damaging the delicate fruit structure. Following this initial wash, trained inspectors conduct visual examinations, discarding any strawberries that somehow escaped earlier quality controls. The surviving fruit then enters the peeling stage, though strawberries require minimal processing compared to fruits like apples or peaches. Some facilities use rotating blade machines, while others employ chemical methods involving hot water or specialized solutions that loosen skins without affecting the underlying fruit. Here's where the process becomes truly interesting.
Not all strawberry follow identical pass through the factory.
To achieve the perfect texture that consumers expect, approximately 70% of the fruit gets processed into smooth puree, while the remaining 30% stays whole or in larger pieces. This deliberate division ensures the final product contains those satisfying fruit chunks that provide textural variety. The mechanical cutting systems operate with remarkable precision, breaking down fruit to predetermined sizes while preserving the natural characteristics that make each piece recognizable. Advanced weighing stations use high-precision sensors to measure exact quantities, calculating the perfect sugar ratios needed for optimal preservation and flavor. Next comes the cooking phase, where industrial magic truly happens. Massive kettles gradually heat the fruit mixture under carefully controlled conditions. This step serves multiple purposes. It breaks down cell membranes, releases natural pectin that creates jam's characteristic gel-like texture, and begins concentrating flavors through moisture reduction. Temperature control during cooking requires extraordinary precision. Too little heat and the pectin won't activate properly. Too much heat leads to caramelization that darkens the jam and creates undesirable flavors. Experienced operators monitor multiple indicators simultaneously, adjusting heat intensity and cooking duration based on fruit moisture content, batch size, and desired final consistency. Water additions sometimes become necessary to prevent mixture from sticking or burning, but this requires extending cooking time until original volumes reduce by approximately 1/3. The entire cooking process can utilize either atmospheric pressure in open kettles or vacuum systems in sealed vessels, depending on production requirements and quality specifications. Following initial cooking, the mixture moves through screening turbines that remove any remaining skin fragments or unwanted particles, ensuring smooth texture throughout. The refined mixture then enters steam-heated mixing tanks where essential ingredients join the formula: sugar, ascorbic acid, citric acid, and additional pectin in precisely calculated proportions. These additives serve specific functions beyond simple flavoring. Ascorbic acid prevents color degradation and acts as a natural preservative. Citric acid balances pH levels and enhances pectin activation. Additional pectin ensures consistent gelling properties regardless of natural pectin variations in different fruit batches. The mixture then enters batch vacuum concentrators where moisture reduction continues until reaching the target concentration measured in degrees Brix, a scale indicating soluble solid content, primarily sugars. Commercial jam must achieve minimum 65 degrees Brix to ensure proper sweetness levels and preservation characteristics. Quality testing becomes critical before packaging. The traditional water test involves dropping jam samples into glasses of water, properly cooked jam sinks without dissolving. The cold plate test places jam on chilled surfaces. Correct consistency means the product holds its shape when tilted rather than running like liquid. Once testing confirms optimal consistency, surface foam gets removed to create uniform appearance, and the jam transfers to new containers, preventing overcooking that could affect color and cause unwanted crystallization. The packaging process begins with glass jar sterilization using steam and filtered air systems, ensuring complete sterility. Automated filling machines dispense exact quantities into moving jars on conveyor systems. Immediate sealing with safety caps protects against contamination, while cleaning systems remove external residue before labeling application. Rapid cooling follows, promoting vacuum formation inside sealed jars as cooling jam contracts slightly, creating tight seals that extend shelf life considerably. Finally, completed jars move into sturdy shipping boxes for distribution to storage centers requiring optimal environmental conditions: cool, clean, dry spaces with proper ventilation, ensuring quality preservation until consumers purchase and enjoy the final product. This remarkable transformation from fresh strawberry to breakfast staple demonstrates how modern food production combines traditional preservation principles with advanced technology, creating products that satisfy millions of consumers while maintaining safety standards and consistent quality across massive production volumes.